Hello there guys, welcome back to another epic inexorable maths video. In this video we're once again looking at the Weierstrass substitution and we want to compute the integral of 1 over 1 plus 3 cos x. And again we're using the Weierstrass substitution. As in the last video, because this is the second video on the Weierstrass substitution, I'm going to link in the description the T formulae playlist and also the Weierstrass substitution playlist as well. Where we're basically, so you can see all of those derivations and examples of how to use this stuff. So here we have a few important things. So these are the T formulae, and these are the values that you use for the substitution if you do a Weierstrass substitution. So sin x, cos x, and tan x can all be written in terms of T, where T is tan of x over 2. And in the first video, the last video that we did on Weierstrass substitution, we found that dx is always 2 over 1 plus t squared dt when you let t equal tan x over 2 as your substitution. This is basically u substitution, but a specific case, it's always the same substitution. So let's just dive straight into this, guys. As always, we should let t equal tan of x over 2. That means that we can immediately say dx is 2 over 1 plus t squared dt. Okay, so we can rewrite the integral of 1 over 1 plus 3 cos x dx. We can rewrite this as the integral of 1 over 1 plus 3. And what is cos x? It's 1 minus t squared over 1 plus t squared. And what is dx? Well, it's 2 over 1 plus t squared dt. Okay, and then we can try and clean this up a little bit. So we have the integral of, okay, the numerator is just the number 2, and the denominator timesing 1 by 1 plus t squared, we have 1 plus t squared, and then 3 times 1 minus t squared over 1 plus t squared times 1 plus t squared, that's just 3 times 1 minus t squared. So plus 3 minus 3t squared dt. Okay, then we can try and group up some like terms. So we have the integral of 2 over, how many t squareds do we have? Well, we have t squared minus 3t squared, so that's minus 2t squared. And then we have 1 plus 3, that's 4. So 4 minus 2t squared. And as you guys can see, once again, we've turned the integral into an algebraic one when originally it was a trigonometric one. That's why it's so powerful. And then we can just divide the numerator and denominator by 2 just to make things a little bit simpler. And all we have to do now is compute this integral here. Now, there are several ways of computing this integral. I'm going to do it with partial fractions. And, oh, guys, look at that, a little Easter egg from the last video. I forgot to rub this off. This is just from the last video that I did on the Weierstrass substitution. So all credit goes to you if you recognize that. Link in description. Let's go, let's go. So, yeah, let's just go over here and keep working. So what do we have? Well, let's use partial fractions for this. So the first thing to do would be to factorize 1 over 2 minus t squared. Now, what does 1 over 2 minus t squared factorize to? Well, it's the difference of two squares. So we can write it as the square root of 2 minus t times the square root of 2 plus t. Like this. That's the factorization of that. Hopefully you're happy with that. And then, guys, let's put it into partial fractions. By the way, partial fractions, love them or hate them, they are going to come up over and over and over again using Weierstrass substitution, because you're always going to get some big algebraic mess. What arises from that? Partial fractions. So let's do this. We have 1 over the square root of 2 minus t times the square root of 2 plus t. We're saying this is identical to a over the square root of 2 minus t plus b over the square root of 2 plus t, like that. Okay, and if you know about partial fractions, then hopefully this will be an absolute piece of cake. You should do. So kind of cross multiplying and then only looking at the numerators. We have a times the square root of 2 plus t plus b times the square root of 2 minus t, and that's equal to 1. And then what do we do from here to find a and b? Well, we just let t be various different values. So if we let t equal, let's say, minus the square root of 2, we'll have 1 equals a times root 2 minus root 2, that's just 0, plus b times root 2 minus root 2, that's 2 root 2. So 1 equals 2 root 2b, which means that b is 1 over 2 root 2. And then let's work out what a is. So let's get rid of the b fraction. So let's let b equal positive, or let's let t, equal positive root 2. And then that says 1 equals a times root 2 plus root 2. So again, 2 root 2a. So a and b are actually the same thing. A is also 1 over 2 root 2. Okay, now we can go back over here to our integral, and we can rewrite our integral as the integral of a, which is 1 over 2 root 2, over root 2 minus t, plus b, which is also 1 over 2 root 2, over root 2 plus t. So there's a lot of 2's, a lot of root 2's, a lot of t's, and we have this right here. Okay, guys, this looks pretty gross. Let's factor out 1 over 2 root 2, just to make it a bit better. So then we just have the integral of 1 over root 2 minus t plus 1 over root 2 plus t dt, like that. And then what can we do from here? Well, we can actually just compute the integral. So what's the first fraction going to be? 1 over root 2 minus t. What would that integrate to? Well, if you guessed something to do with the natural log, you're absolutely right. This is going to be minus the natural log of the absolute value of root 2 minus t. Okay, why is it going to be that? This is just the first one. Because if you differentiate the natural log of root 2 minus t, you will get minus 1 divided by root 2 minus t. And well, you might say, oh, we don't have minus 1. That's why there's a minus there to offset it. And then the second one is even easier. 1 over root 2 plus t. That's just the positive natural log of root 2 plus t, like that. And then we can put a plus c on the end. And then we can ever so slightly simplify this by basically just combining the logarithms. And we have 1 over 2 root 2 times, and I'm going to write this one first, and I'm going to divide it by this one because that's a rule of logarithms. So the natural log of root 2 plus t divided by root 2 minus t in the absolute value signs, close bracket, plus c. And the very, very, very last step, guys, you might be saying, oh, cool, are we done? Are we done? Almost. Well, it's just that we can't say that the integral, remember, the question we're doing, the integral of 1 over 1 plus 3 cos x, obviously we can't have t in our answer because whoever we tell the answer to is going to be like, what on earth are you talking about? T? Well, it was with respect to x. Remember that t is tan of x over 2. So the final answer is that the integral of 1 over 1 plus 3 cos x with respect to x is equal to all of this, so 1 over 2 root 2 times the natural log of, where is it, root 2 plus t, but t is tan x over 2, so root 2 plus tan x over 2 divided by root 2 minus tan of x over 2. Boom, boom, plus c, don't forget it. Hopefully all of that is readable there. And that's the answer. So the integral of 1 over 1 plus 3 cos x with respect to x is 1 over 2 root 2 times the natural log of the absolute value of root 2 plus tan x over 2 divided by root 2 minus tan x over 2 plus c. A bit of a mouthful, if I do say so myself. But as you can see, the integral looks easy. It actually isn't very easy. The only thing we can do here is Weierstrass substitution. And although it is a lot of algebra and nitty gritty, just algebra, partial fractions, step by step, it's not too bad. It's just the combination of all of it. It can be quite difficult. But hopefully that was helpful, guys, as always. Thank you so much for watching, and I'll see you in the next video. Cheers.